Welcome everybody to this month's YouTube Global R&D. For those of you that don't know me, I'm Dimitris. I'm leading the execution team at DFINITY, and I will be your host for today. We have quite an interesting agenda ahead of us. So first off, we'll have Rudy to give an update on the Levitron Milestone that was completed in the Maxine, an update on stable structures performance improvements, and then we have several demos lined up, ranging from the hackathon participants on the Caffeine event a couple of weeks ago to the SNS Liquidity Pool and some Bitcoin DeFi projects on the IC. So without further ado, let's jump straight into it, and we'll start with Rudy and the update on the Levitron milestone. Rudy, the floor is yours.
Thanks, Dimitris. Yeah, so my name is Rüdiger. I'm representing the Boundary Node team today, and I want to talk about Levitron that we completed last week. Levitron, the name, it doesn't tell you much, but actually it's all about making the API Boundary Node access logs publicly available in real time. So what does it mean? Maybe we can take a quick step back on the next slide. Back in February, actually the Boundary Node team completed the Solenoid milestone, which was all about decentralizing the Boundary Node architecture. This was all about HTTP gateways and API boundary nodes, and since then, the API boundary nodes are the public edge of the Internet computer. So this means you see all the arrows going into the Internet computer, so all the requests coming into the Internet computer go through one of those API boundary nodes. And it doesn't really matter if this request comes from a DFINITY operated gateway, a gateway operated by some other entity, or from some IC native client. So actually the API boundary nodes, they have very interesting information. They see all these requests, and the goal of Levitron was making these access logs that the API boundary nodes connect publicly accessible, so accessible to the community, and this in a decentralized manner. Next slide, please. So with the completion of the Levitron milestone, what you can do now is anyone can stream canister access logs from these API boundary nodes, and what you get, what kind of information is really every single request to a canister is being logged there. So every single request coming from the outside. And among other information, what you will see, you have some client identifier, you have what kind of request type it is, so whether it's a query or an update call or a status or a read state. You will see which canister method was called. You see how big the request size was, the response size, and a lot of other information. For example, in which subnet the canister is hosted, which replica node actually replied to this request, and so on. And why did we make this publicly available? It's really super valuable information for developers and the community. For example, it allows developers to track canister usage. It also gives visibility into the query calls, which was or is otherwise very hard to see. So you could think of use cases. I have some canister endpoints. I want to retire them, but I have no information whether they're being used or not. You can look into the API boundary node access logs, and you will at least know whether somebody from the outside is calling these endpoints. It also gives the ability to gauge a bit the network activity, and it can also serve as a data source for these ranking and analytics platforms. So for your application, for your dApp, you might use this to get some information about daily active users and so on. And how we do this is each and every API boundary node exposes a WebSocket endpoint. You can directly connect to this WebSocket endpoint and start streaming canister access logs. You will get the logs in real time, but you don't have access to historical data. So if you want to build, some database, it's all up to you. But in this sense, it's decentralized. You get the data from the source. And next slide, please. With this, I'm already at the end of my little announcement. I just want to encourage you to check it out and start streaming the access logs. I linked you the blog post, the developer docs, we have a sample client that kind of showcases how to discover the API boundary nodes and start streaming. And we have a forum thread where you can leave all your feedback and questions. And with this, and just have to thank everyone involved, especially Igor, who actually implemented most of it. And yeah, thank you. Back to you, Dimitris.
All right. Thank you, Rudy. Very informative. And now let's move on to the stable structure performance improvements that came with the latest release. Maxim, tell us more about it.
Yeah, hi. Thank you, Dimitris. My name is Maxim, and today I'm happy to announce that we got a new stable structure release, which is mostly performance-focused release, and this is the version 0.7. So the goal for this release was clear. Picture map, one of the core stable structures, previously showed from 10 to 100 times overhead versus the direct memory access. And that is a not theoretical issue. Actually, it was reported externally on our GitHub issue page, and it was also confirmed internally by our internal teams who use stable structures in their production environment. So how did we improve it? The way we improved it was the first step. We actually improved another thing. It was our benchmarking tool that is called CanBench. And with this improved tool, it helped us to clearly see and prioritize the optimizations, which included removing some extra cloning, introducing some lazy iterators, removing unnecessary deserialization of big keys, and speed up the tree traversal. Next slide, please. Yeah, so as I said, with this newly improved benchmarking tool, CanBench, it also allowed us to see real and measurable impact. And you can see by the number of green colors, it's mostly improvements. So I have a few examples. For example, the B-tree map structure has about 300 benchmarks, and only 24 of them regress just a little bit. Sorry. Yeah, so it regressed a little bit, just 13%. And the other part, the much bigger one, almost 200 benchmarks actually improved. The median improvement was 5%, and some cases were up to 98% of gains in the number of instructions consumed. Another example is heavy input-output use cases when reading and writing chunks of data. This is a synthetic test, but nevertheless, the improvement, median improvement was around 50%, with the best improvement more than 80. Another important case, which is actually a real production workload, is an SNS canister, and the median improvement there was about 20%, with the best case more than 50%. And lastly, the original GitHub issue that was actually caused all this work. It's actually trying to store 100 megabytes in stable memory through different means. And now you can see that it got faster from 2 to 4 times, depending on the way you store those chunks of data. Next slide, please. Yeah, so with all those improvements, actually came some breaking API changes. And I would like to state here that there is no memory layout changes, meaning that it's safe to upgrade. The existing stable memory data that you have in your canisters, it remains valid. So the only breaking change is actually in the API methods, and those are just 3. So the first one, we had to add a new method called into bytes into storable tray. And with this, it avoids unnecessary cloning and speeds up the map inserts. The second change is we changed the iterator. Now it iterates over lazy entity, which avoids the deserialization every time on key value. So it's not iterating over key value tuples anymore. And you only access keys and values on demand if you really need them. The third breaking API change has nothing to do with performance improvements. It was a long-standing question that we had to do at some point when we are cutting major release. We wanted to unify all the methods across different stable structure types, and we decided to remove returning results and panic instead. First of all, our main stable structure type, BTMap, is already doing this. This is first reason. The second one is those errors were not actionable because they were unrecoverable anyways, because you had to reach the limit, memory limit, which is huge, like 500 gigabytes on the subnet. And with this change, it simplifies the usage. It removes the boilerplate and makes the code cleaner and easier to use. Next slide, please. Yeah, thank you. So basically, the migration steps are very easy. You need to fix build errors, and that's it. You need to implement into bytes for your storable types. You need to switch to a new iterator, not using key values tuples anymore, and use the lazy entry. And the third one is to remove all the unwraps from the methods that now panic. The next slide, please. Here, I would like to say thank you to everyone who helped me with this work, specifically the SNS team who provided a real-life benchmarks and a lot of performance insights. Also, a special thanks goes to David Franks for his consistent contributions and great ideas, and actually for the original proof of concept for lazy entry iterator. And to everyone else who shared their feedback, filed issues, and helped testing it. Without you, this release wouldn't have happened, and I encourage everyone to go and try this new release and share your feedback. And that's actually all from me. Thank you very much. Back to you, Dimitris.
Great. Yeah, thanks, Maxime. I hope people like this new release. And yes, I will second your suggestion for people to try it out and give us feedback. We really want to hear your thoughts. And with that, we're over the updates, and now we're moving on to demos. So first, we'll have an update from Caffeine from the hackathon that happened in NSF a couple of weeks ago. We'll start with Bruno that will give us a short intro, and then we'll hear from the hackathon winners and see what they were able to build. So, Bruno, feel free to take it away.
Okay. Hello, everyone. Thank you so much for the chance to share what happened a couple of weeks ago in San Francisco. So it was an amazing experience to first showcase to the world what Caffeine can do. And it was very cool that we had the setup of putting together a hackathon. And this was not the normal hackathon that you usually see. We've been able to put together a special structure where we had 80 participants, where 40 of them were technical and 40 of them were non-technical. So basically the two tracks that we were covering was a tech track and non-tech track. At the moment, we know that basically the main difference between the two tracks was just the fact that the experience that the people had participating in the two different tracks was completely different. Some of them were developers, IT, major with computer science, while others were just normal people that have zero experience with programming languages. And we saw that the results that came out of this hackathon were impressive. We were supposed to run the hackathon for around 7 hours, but then at the end, we just ran it for like 4 hours and something, and the results were anyway amazing. So something that we would been able to show up out of this is, first of all, an amazing inclusive innovation, meaning that we've been seeing coders and non-coders building apps together. We validated the proof of concept that Caffeine as a no-code app development is the platform that everybody needed. ICP in action. For sure, this was amazing to see all these application being launched and go live fully on chain, and the outcomes of what has been built in few hours was pretty amazing. Now, some cool data that I like to share is the fact that in just 4 hours, out of 80 participants, we got more than 270 plus applications that have been built. And we've been seeing that the demographic of the people attending were going from developer, designer, entrepreneur, students, doctor, lawyers, founders, basically everybody was there. And this was a very, very cool experience. If we can go to the next slide, please. So because of time constraint, we don't have the time to allow for all the winners from the non-tech and the technical track to share what they did. So I'm just going to give you a quick showcase of what the winner from the non-technical tracks have been building. You can also check the presentation. There are the links, so you can also test out the application that have been built. And then after this, we are going to see the 3 winners from the technical track that are going to take the stage, and they're going to showcase and present what they've been building with Caffeine and what kind of upgrade they did in the last couple of weeks. Let's go to the next slide, please. So the first place for the non-tech track was Blue Lens. As you can see, this is already looking super amazing as an application, web application that has been built. And this was an application built for monitoring the safety of the drinking water that you get in your house, in your home, or where you live. Next slide, please. The second winner instead was a lawyer. She created an application where basically you don't have to use any more notary or lawyers, and you can actually draft your will on your own just by using this application. And this application has been fully built by leveraging the legal knowledge of the winner, that has been put everything in one website where you can just use it and you are able to bypass the legal standard. The next slide, please. And then the third place was won by a dentist. So the dentists know that there are some pain in the healthcare system, and this especially the one of keeping track of medical data. So this application after can be taken as a reference for other healthcare initiatives. But basically this application that she built was just an application to keep track of everything you're doing when you go to your dentist, and a unique place where you can collect all the information from whatever dentist you've been going in your life. Next slide, please. And this is the time to give the stage to the 3 technical winners. They are going to share what they built, how they come up with this idea, how was their experience with Caffeine. Just a quick reminder to the 3 winners that are going to present. You have only 3 minutes to showcase what you're doing, what you did. Thank you so much, everyone.
So just to make sure that, there are many people here, can you write anything to the chat so that I'm sure that, you're also listening, and because I want to share something really, really cool. Just write listening. Yeah. Awesome. Yeah. Paul, thanks. Claudia, thanks. Yeah. I think we are like all around the world, right? So it's like early morning right now in San Francisco, California. Okay. Yeah, I see. Yeah, thank you. So yeah, okay. Okay. Recent things, right? So there was an app called T. It was hacked 2 days ago. The reason was like database keys were open to everyone, and now the whole United States map is full of leaked ID images and other sensitive data, and that happens every single day to many folks. So I built a one-click app protector, which you all want to see now, because in the end, I will tell you just how to avoid such issues. And, I think there are many people here who are also non-technical, but you definitely try Caffeine AI or any other tools, So, and I believe in the next couple of years, you will also use coding more and more in your daily job. So listen carefully. when you build nice apps, there is a chance you will expose some of your credentials to the public. If that happens, some hackers or other people can use this. For example, during the Caffeine Hackathon, I built a small app where I put this API key just to showcase that it could happen, right? And that happens to, professional developers. For example, only on GitHub, there are like over 10 million credentials they are leaked every single year, right? Even 15 million, sorry. And that's why I built K. I built it during the hackathon, and it simply takes any Caffeine app link and then makes an 11-layer security audit where it tries to find all exposed credentials from the app. There is a video how does it work, right? So we just enter a URL. This is an app which I built, which is like a GPT wrapper where the API key was exposed, and then we see a lot of different security issues, so with different severity. So like some of them are critical, some of them are not. And the idea basically is just to help people build more secure applications. And then, yeah, I'm live now. I have a website. It's canwithk.com. I have a wait list packed now. I think, the hackathon gave me a really good kick. So there are many people, they are, DMing me every single day how to protect their apps. I think there's a huge opportunity here, because then we can start with Caffeine apps, then scale to other platforms, and overall make the vibe coding experience more smooth and secure. My ask is like, ideally I want to go further and integrate more deeply with Caffeine app on a build level. So yeah, hope you enjoyed this small presentation.
Very cool. Yeah. Thanks, Alex. Yeah, I guess that sounds very interesting to me. Let's see if people pick up your challenge and start using it. Chelsea, how about you? Are you able to solve were you able to solve your issues?
Yes, I am good to go now.
Perfect. All right. Then the stage is yours.
I'll go ahead and share my screen. So the app that I made for the hackathon is called Skill Sprout. Essentially, it is a hobby discovery and skill progression app that's entirely based around a garden theme. So the idea that I introduced was potentially enabling users to learn and discover new hobbies by removing the barriers that come along with learning those new hobbies. So we'll start here, which is where we have our little greenhouse of hobbies. When we go to our explore page, that's actually where we get to explore the currently supported hobbies. So the ones that I actually just built in during the hackathon are these sticks. If you choose to learn any of them, I think one I haven't, we'll just go through watercolor painting right now. So for each of these, this one is starting completely from zero. We have nothing done here. The first barrier that I really wanted to remove for people wanting to try a new hobby was knowing what materials they need in order to do that hobby. So the first thing we have here is materials and equipment broken down by essential versus nice to have. I personally think it would be really cool. It's not hooked up yet, but if we were able to link these perhaps to affiliate links through either Amazon or something that's pre-compiled and ready. And then from there on, we also have a skill building path. So for watercolor, this is going to be custom for each of the hobbies. But for watercolor, we're going to start with learning the basics, things like the properties, brush types, techniques, supplies, setting up the workspace, and more skill building paths. And so also, I wasn't able to get this hooked up exactly to the YouTube API. I was trying to set up a proxy to do it during the hackathon, but there wasn't enough time. Something that I was able to do to kind of subvert this is I actually just asked Caffeine to return the YouTube search results for whatever that skill was titled. So that's what it does, and it does it quite successfully. So from here, users can actually just mark off each of these as they've done them. So when we go back to the home page, it actually shows each of these hobbies as different stages of growth. And I found that by using emojis, it actually works quite well to show the progression of each of these hobbies. I also inbuilt a little hive feature that's supposed to allow users to actually encourage each other to keep growing on their hobbies, kind of similar to pollinators and bees. So it's a sort of forum style post and reply sort of configuration. And that is Skillsprout.
Very cool. Yeah, thank you. I mean, searching up results on YouTube, yeah, that's pretty damn amazing. Yeah. And now let's complete with Daryl, the big winner. Big round of applause. So Daryl, take it away.
Reason why I built Road Patrol is, like I said, I've been in the transportation industry for a few years, and I've been building, full stack web apps, systems to integrate with the government, specifically the transportation industry. So that's kind of where my idea came from, because I did try to look into different applications that we can use to report, not just potholes, but like trash, street lights, broken street lights, places that need a stop sign or something. And I couldn't really find anything. So, all right. So, quick overview. This is Road Patrol. So we're going to go ahead and log in. So I've already picked a username, so it should automatically redirect me to the dashboard. So yeah, so it seems like there's people who've been adding reports. So the way it works right now is anybody can add reports from anywhere in the world. But the way I want it to be is it being city based, and that's kind of what I'm doing, and it's already functioning that way on my local machine. But yeah, so what you do, you just come over here, add a report, say pothole, or like, let's try something different. Pick a category, critical, location. Say San Diego. Let's pull in all the different locations. So it actually checks to see what kind of photo you're trying to upload. If you try to upload a photo that's not appropriate, it's going to error out. So let's upload a sinkhole photo. And then when you upload it, it converts the image into WebP, which optimizes it for the web. So that image that we just uploaded was like 3 MBs. Then you submit it. And there it is. And so in the chat, there's like little bot commands you could do, like top contributors, then send that, and then it will give you a little report. We got 3 reports. No, 3. Yeah. 3 reports from TKH. Yeah, it's kind of detailed, but yeah. So what I'm trying to do is I want to add so the points are going to be token based. So they're going to be actual tokens that you can swap for real value money. And they're going to be kind of like a mining type of thing where you post and you get a certain amount of points. And that's the only way you can get the points, and they're not pre-mined, and it's a fixed supply of like 21 million points, just like Bitcoin. And there's just so many features I want to add, but But yeah, that is Roll Patrol.
All right. Yeah. Thanks, Daryl, and everybody else. Really great to see what people were able to do and build in like just a few hours. All right. So now we're gonna move to the rest of the demos. Next up we have Arsavir. He's gonna talk about the SNS Liquidity Pool. Arsavir, feel free to share your screen and tell us all about it.
Yes, thanks, Dimitris. Hello, everyone. So I'm Arshavir. So some of you have already heard that we're building a proper liquidity pools integration feature for the SNS. And the question is, what is this about? So why is it that we're calling it proper? So first of all, currently some projects are already able to allocate liquidity, but this requires a lot of work. And as a result, it's very hard for the community to judge what these low-level proposals for treasury transfers actually accomplish and how to get their tokens back if something doesn't go right. So even many months after launch, some of SNSs don't have their tokens in a state that is easily tradable. So what we're doing here is adding an SNS extension, which is going to be a separate canister, and it can be viewed as one canister per DEX, allowing SNS projects to choose which DEXs they want to allocate liquidity for, and then opt in for that. DFINITY is working on the template for one of these DEX extensions, and we're using Kongswap for this purpose, but we also are hoping that others will pick it up and produce more SNS integrations for other DEXs as well. So at this point, I want to hop onto the IDE and show you a little bit how this would work. So I already have a testnet that is running an SNS. And in that SNS, all I need to do to register a liquidity pool extension is to run a single CLI command. So I'm going to copy this into my terminal and run it like so. So let's quickly go through this. So this is the SNS CLI, our standard tool for interacting and managing SNSs. And it simplifies creating a proposal to register a new extension for us. So what I need is to have one of the extension WASMs that has been approved by the SNS. At first, when this feature will be launched, it will only be one possible canister that you can install, but in the future, maybe there will be hopefully more options. The standard boilerplate fields for proposals include the URL and the summary, and I tell the Neuron ID that I want to use to submit such a proposal for registering this extension. And finally, which is very important, is that at this time, I can already provide the information about the initialization parameters for my SNS extension. Since this is what we call a treasury manager extension, it is going to work with various token amounts. And here I can specify that the ICP amount is going to be 100K and the SNS token amount is going to be 200K, just some toy values for this demo. That's it. The proposal has already been created, and on this testnet, it went through right away, which we should be able to validate. We have a timestamp for when it was executed. Great. Now, how can we actually interact with the extension? So if I call this command, this dfx call SNS root list SNS canisters, it already existed before this endpoint, but it used to only provide all but the extensions. And this is the new part. So you can see that when we're registering an extension with SNS framework, it's also recognized by root, which becomes a controller of the extension canister. This simplifies observability, because now if we need to read some information about the extension, what it's doing, what its status is, we can just directly query that canister. So I'm going to basically set this as a local variable and then run a few more interesting commands for you to see how this works. All right, so next up, let's check one of those queries that I mentioned, namely the one that gives us all the balances that are currently managed by our SNS extension. So if I go to this JSON file, I can show you that it actually has a very simple structure and could be prettified by a nice front end in the near future. But so far, this is how it works. So you have two tokens, one for ICP, one for SNS, and they are represented with these assets specifications where you have the ledger canister IDs and other metadata such as the fee and the symbol. And for each of these tokens, you can see exactly how much our SNS extension thinks that everybody has who's involved in managing the treasury assets. So you might be asking, like, what does it mean, everybody, right? Like, what are the parties involved in this process? So to explain this, let me quickly go to the candid API of our SNS extension, and it is heavily documented, including this diagram over here, which illustrates what parties there can be. So if we quickly go through them, then one of them is, of course, the owner of the assets. And in this case, it's the SNS governance, right? The treasury manager, that is our SNS extension itself. The external custodian is the DEX backend. So we know that it exists, but we might not know which ledger accounts exactly are used to manage our assets. And the fee collector, which is important so that we can keep track of the fees, because different ledgers might change it from the standard value. Then there's a theoretical possibility that there's some inflow and outflow of the assets, and for simplicity, we will omit this for now. And this leaves us with the following simple diagram for the two flows that we have. The initialization flow, and that also creates this initial deposit that I explained, starts with some amount of tokens that the treasury owner has, and those then are transferred to the treasury manager. And later, the treasury manager transfers them to the external custodian, which is the DEX. And of course, each of these transactions is also adding some of the tokens to the fee collector account. And for the withdrawal, you can see a similar situation, but we're unrolling this pipeline starting from external custodian, treasury manager, we go to treasury owner. So this is the cash flow that we're expecting. And then if we go back to our balances, this information helps you to understand what this actually means. So when we successfully deposited 80K tokens, we know that 20K was paid to the fee collector. In this case, you can see that these are comparative numbers. In the real world, we expect the fee collector to usually be very, very small. But of course, it needs to be monitored because there could be a situation in which one of the ledgers has a very high ledger fee. We don't have control over that. Okay, so we're almost at the end of it, but let me also show what happens if you want to top up your existing liquidity pool. So that's another instance of deposit. And for that case, you don't need to register a new extension anymore. You can reuse your existing extension. However, this cannot be done by anyone, right? Because it's a treasury management operation. It needs to go through another SNS proposal. And for this purpose, we have this new type of proposal that is upcoming very soon. It's called execute extension operation. And in this case, the parameters of that proposal are the extension canister ID that we already observed, the name of the operation, which in this case will be deposit, as well as the argument. And here you can see that the argument that we're going to be using closely resembles the one that we used in the initialization flow. And you can think of the one in the initialization flow as simply an optimization that, prevents it. We're not requiring that the SNS submits 2 proposals for the initial deposit, one to register and one to top it up. So if I run this, then this will create and in case we can check whether this proposal has succeeded. And in this case, what's interesting is that you see that the proposal has not succeeded because you can see that the timestamp is still 0. So you might be questioning what to do next. So the good news is there's an audit trail, which is another query. So if you call the audit trail function, then any user, any member of the SNS community could use it to be able to observe any user should be able to use this audit trail to observe and debug what went wrong in case they have any questions. So with that, I thank you very much for your attention and return it back to you, Dimitris.
All right. Yeah. Thanks a lot, Arsalir. We have one more demo and we're right on time. So we'll have Christopher now, who's going to walk us through some of the Bitcoin DeFi projects on the IC. Christopher, the floor is yours.
Thank you. Yes, so I wanted to share with you an introduction to this initiative that we call the Bitcoin DeFi Initiative internally, and also a glimpse into an introduction and a glimpse into what we're working on and what you will be seeing in the future regarding Bitcoin DeFi on ICP. So I'm starting with a few fast slides to just sort of set the stage why we believe this is important. And so these are quite leading questions. What do these projects all have in common? You have Liquidium and Odium and Rich Swap, etc. And the answer, of course, is that they use Bitcoin tech and they are built on the ICP. And throughout this year, we have seen a fair amount of growth within this vertical, so to say. The amount of CK-BTC locked on ICP has grown substantially. So soon everybody will be driving Lambos. And also, of course, the amount of users and the amount of applications, that is, I believe, one of the coolest metrics. The number of applications doing Bitcoin DeFi stuff on ICP has really grown. So what we want to do with this initiative is that we want to tap into this momentum, so to say, and of course accelerate this whole trend. And one of the most important things is that we would like to remove as much friction as possible when onboarding new Bitcoin developers onto ICP, because we have seen that this is a really fruitful combination, and we want to see many more great Bitcoin DeFi projects on ICP. So this Bitcoin DeFi narrative is sort of like an umbrella term or like almost like a campaign that we will be pushing for throughout the fall and longer. That has to, we will keep working on stuff that you see on the screen here. We have done updated developer docs. We will create easier ways to get cycles, because if you're a Bitcoin developer, you don't have any ICP perhaps, and it would be good if you can get cycles easily. So, and the new and updated examples, apps, etc. But I'm not going to talk about that. I'm going to show it. That's the important thing, right? This is the demo section. So starting out, we have this landing page. We simply called this whole initiative bitcoindefi.dev, and we created that website with a targeted message to Bitcoin developers primarily. So the ICP information has sort of jumped into the back seat, so to say. So we speak with Bitcoin developers using Bitcoin native, Bitcoin first language, so to say. So this whole thing is meant to be sort of like an onboarding funnel to make Bitcoin developers excited in the possibilities of building Bitcoin DeFi applications on ICP. So that is the first layer, which is this landing page. This is almost published. Things like DNSs, etc., take time. So you will see this website being published in the coming days on the bitcoindefi.dev domain. Then the second layer, which lives on the same website, is the high level documentation, or not documentation, high level information to Bitcoin developers, sort of describing the bridge between Bitcoin and ICP. So first, it describes a little bit, how the anatomy of Bitcoin applications. It describes all the smart contract capabilities of ICP. Sort of tries to translate the Bitcoin capabilities into ICP language. And then we did a few case studies where we break down the technical architectures of projects like Odin, Liquidium, and Omnity to really, help developers coming from outside the ecosystem understand how you could structure your application on ICP, and hopefully plant seeds to new ideas in these developers' heads. And then throughout this website, we link heavily into the regular Bitcoin developer documentation. So let me jump to that one next. So our hopes are that you start off on the landing page, you go to the second level, get even more excited in building on ICP, to then click onwards onto this new and revamped documentation, the developer documentation section on the regular internetcomputer.org website. And this section has been given a more prominent position here in the top navigation of the developer docs. We have overhauled all pages. We have everything from setting up your developer environment to describing the Bitcoin API endpoints, to in detail describing how to create the transactions and sign transactions, etc. And now also that all this information comes with revamped and improved developer code examples that are heavily documented and very straightforward to read and understand. And what also is new is that we have added to this documentation section information about Bitcoin assets, which has been highly requested. And that is also included in the Bitcoin examples that we provide. So here you have code snippets on how to, also heavily documented code snippets on how to create ordinals, runes, and BRC20 tokens. So that is one track of this initiative. And then we have another example application. So if you really just want to quickly get a taste of what you can achieve, you can head over to ICP Ninja, and there prominently on the first screen we have this Bitcoin wallet sample application that you can open up yourself in the ICP Ninja editor to just get a feel of how an application is structured and what you can do, and you can try it out. It works. It's a very, very simple UI-based wallet that derives an address for the currently logged in user. So you log in using internet identity, and then the canister will derive a Bitcoin address for you. And then you can receive and send. So this app lives on mainnet. There's a testnet version. Be sure to be careful with your funds. I'm approaching the end of what we have done so far. And this is that is all stuff that we have already completed, and that is all available. The website is coming in the coming days. And the last exciting thing that we will be launching together with the community project is something called getcycles.dev, where the actual website will then jump into the back seat, and what the most developers will actually use is an extension to DFX. So assuming that you have set up your project locally, and you are building this Bitcoin DeFi application, and you're a Bitcoin developer, you only have Bitcoin and you don't have any ICP to convert into cycles, then you can use this Get Cycles DFX extension that will derive an address for you. You can transfer a small amount of Bitcoin to that address, and then just issue a CLI command to convert those Bitcoin directly to cycles and top up your developer account, so you can deploy your application without having to know much about ICP. So again, all about reducing and removing developer friction, I would say is key here. And then going back to this overview thing. So in addition to I've covered most of these things. Yeah, we will also be attending conferences. So the next one will be Bitcoin Asia, to really interact with the developer community. And of course, we will try to also keep working with the website and social media channels, etc., to publish. We will be doing streams, and both on a high level, more like business-like, and more on a technical level, and publish blog posts and do spaces and videos, etc. All in all, just to try to accelerate and help this Bitcoin developer ecosystem on ICP. I think that's it for me. Thanks.
All right. Thanks a lot, Christopher. And with that, we're at the end for today. Very special thanks to the Caffeine Hackathon winners that joined us as well. That was very interesting to see. And thanks everybody else as usual for joining. Tune in next week for a regular Global R&D, and then we'll see you also next month for the next YouTube one. Until then, take care, everybody.